Welcome to today's webinar. The topic today is automatic creation of load combinations in RFEM 6 and RSTAB 9. My name is Andreas Hörold. I'm responsible for marketing and public relations in the Dlubal Software company. For instance, the webinars, the Dlubal website, customer projects, etc. I will be the moderator today and also the presenter. My two colleagues will support me with answering your questions, and they can introduce themselves.
Okay. Hi, I'm Caroline Lessmann. I work here at Dlubal Software in the marketing department, so I basically support Andreas Hörold in all his tasks, and I'll be answering your questions today.
Yeah, hello, my name is Stefan Frenzel. I'm working here at Dlubal in the product support and of course in product development for the dynamic analysis. And I will also give you answers to your questions today.
Okay, thank you for your introduction. We can switch off our webcams that the attendees can see the full screen. You can ask questions via the control panel on the right side of your screen. You can enter a question here and my two colleagues will answer you. If there are too many questions during the webinar and you won't get an answer, you will get an email after the webinar. The other way is to watch the entire webinar and email your questions to info@dlubal.com. To the agenda today, I will create a simple example. You can see that on the right side here. Steel frame, and I add load cases and imperfections. Then follows the automatic creation of load combinations. That's the main part of the webinar. Then reduction of the number of load combinations and consideration of initial states. Then let's turn to the program. That's the finished model, but to show you all options in all dialogues, I will start with a new model. Here left above, File, New. I call it Frame. 3D model is okay. Then it's important to check here combination wizard and classification, that the load combinations are created automatically from the program. Load wizards for snow and wind. We don't use it for the steel frame. I can leave the check here. I activate two design add-ons to show you where you can assign the design of the add-ons in the dialogue, load cases and combinations. So then standards 1, there are a lot of standards implemented for the load case classification and the combination wizard. I use the Eurocode 0, and we are here in Germany. I use the German National Annex, but as you can see, there are almost all national annex from the European countries are included. We don't use any load wizard, but you have also a lot of standards implemented here. Just a moment, I have to mute my colleague. Okay. Then, the design standard groups for concrete and steel, but since we don't do a design, I can leave the standard setting. Okay. Then that's the new model. Here right above, I change the view in reverse Y direction and change the plane to XZ. So I zoom a little bit in and start with the first member here left above with a beam section. I use a section from the database, I-beam standardized. AGA 200 and just a moment, I take a steel as 235, okay, and leave the dialog. Okay, the column should be 3 meters high. Okay, then the horizontal beam 4 meters in X direction. So then I add a nodal support here left above, nodal support, and I use a fixed nodal support. Okay, we can take a look at the settings. Yeah, fixed in all directions. Also the rotational, all directions are fixed. Okay, then I add it here. And then with pressing the Control key, I can copy that via drag and drop to the other side. Now the frame is finished. As you can see above, the self-weight load case is automatically created. We can add a member load for the self-weight load case, 1 kilonewton per meter. Okay, then I create a new load case with that button here, new load case, and I call it snow. I assign an action category according to Eurocode 0. In that case here, the snow ice loads with a height under 1000 meter. Okay. So I add the next load. A uniform load, 3 kilonewton per meter. Okay, then the next load case, wind plus X. And I assign the action category wind. Okay. Member load again, this time in X direction, 2 kilonewton per meter. Okay, I can reach the dialog with the Enter key. Okay, again in X direction, 1 kilonewton per meter. Okay, load case 3 is finished. And now I open the dialog load case and combinations in the navigator data by right click. Okay, load cases. I will come back to that dialog later. So now there are different options. You can create here left at the bottom, create new load case, then copy selected load case, and the other option is add loads to new or existing load case. I use the option copy selected load case. So I rename it and call it add with wind suction. Okay, all loads are copied. You can see that we are in load case 4. I add the load on the horizontal beam, minus 0.5 kilonewton per meter. Okay, also this load case is finished. Then the same workflow, I copy wind load case 3 again and call it minus X or rename it in minus X. And with double click, I come to the dialog edit member load and I change it to -1 kilonewton per meter and this one to -2. Okay, load case 5 is finished and the same workflow for the last load case. I am at with wind suction. Okay, and add the load on the horizontal beam. So all loads are created. New in RFEM 6 and RSTAB 9 is that you don't have to create imperfections as load cases. In RFEM 6 and RSTAB 9, you have to create imperfection cases and then local imperfections. I will show you the workflow. I could reach the dialog by right-click here in the navigator data, new imperfection case. The other way is to use the menu here above, insert, imperfections, imperfection cases. So first imperfection case, imp plus x. And in this dialog, I have to assign the load cases, the right load cases that act together with the imperfection in plus x direction. That is load case 3 and load case 4. Okay. Then new, I left at the bottom here, I create a new imperfection case, imp -x. Okay, and assign load case 5 and load case 6 to this imperfection case. I leave the dialog and then I can create a new imperfection, a member imperfection, right click, new member imperfection. Yeah, I assign an initial sway on the columns according to Eurocode 3 and 2 and 3. Okay, that's also okay. Then I measure the height of the columns, 3 meter. Then 2 is the number of columns in one row. Yeah, and that's all. And I have to assign the right imperfection case. Okay. So then I have to select the 2 columns. So, and here above, I have to show the imperfections. So first imperfection is created. Then I can create the imperfection for the imperfection case 2. I can do that here in the navigator data again, but I will use the option over insert, imperfections, member imperfections, dialog box. Initial sway again, the same definition type in -z direction, 3 meter, and 2 columns in one row. So, and then I have to assign it to the imperfection case 2, imp -x. Okay, to select the 2 columns again. So this is imperfection case 1 and 2. So that's all to the imperfections. Yeah, now all is completed. Also that means the imperfections and the load cases. And I go back to the dialog, load cases, and combinations. I start with the base dialog. Yeah, at the beginning, we selected the standard Eurocode 0 and the German national annex, and we already set this check. We use the combination wizard to create combinations automatically according to this standard. So result combinations, I have to say in RFEM 6 and RSTAB 9, the most unfavorable constellations of load combinations are determined in the design situations. You can see that here. Both we will come to this dialog later. You don't need to create any load combinations for designs in the add-ons. As I mentioned, we will do that in the design situations. And generally, load combinations are created for the structural analysis to determine nonlinear effects correctly. Result combinations, however, superimpose the results of load cases or combinations. It is maybe necessary, for example, for dynamic analysis. I will show that in the last example. Then we will use the result combinations and the sub-results. Okay, then parentheses. For example, if you would do a criterion nesting, for example, you could set combination 1 or combination 2 in brackets. That would be, for example, possible. And sub-results make it possible to specify additional combinations that can be used for the design. I will use that option in the last example. Then combination names according to action category. That means then the load cases and load combinations are not called LC1, LC2, etc., but G, QS, QW, etc. Then generate load cases from construction stages just before calculation. We don't activate the construction stages design. If you want to see a webinar about this add-on, you can find it on our website. At the end of my presentation, I will turn to the website and show you how you can find webinars, also previous webinars. We presented webinars to almost all new add-ons, also all add-ons of RFEM 6 and RSTAB 9. So then load cases, we were already in this dialog. Maybe some additional information. For the self-weight load case, the structure self-weight is activated by default. You can see that here on the right side. Then the default setting is geometrical linear, but you have also the option to use the second order or the large deformations analysis. Okay, then the action category. You already seen that. According to the standard here, it controls the superposition of load cases and the partial safety and combination factors. According to the selected standard, in our case here, Eurocode 0. Then the wind load cases, the imperfections are considered. You can see that here. Load case 3, wind in the X direction, works or acts together with the imperfection in plus direction. Also for this one, and the wind minus X acts together with imperfection case 2, imperfection in minus direction. Okay, structure modification, consider initial states from. I will come back to these options later. So gray are also the add-on structure stability add-on construction stage. As I already mentioned, I will show you at the end how you can find webinars about these add-ons if you are interested in. So then actions, permanent, snow loads, and the wind loads. Yeah, different action types are available. For example, simultaneously, all load cases of the action can be combined as desired. Alternatively, yeah, that's for assigned to the wind load cases. Yeah, only of one of the actions of the load cases can be effective in the combination. Then we have already the option differently. Load cases can be assigned to groups. I can show that. For example, I can add here 1, 1, and 2, 2, means 2 groups. And load cases act alternatively within one group. And load cases in different groups can occur simultaneously. So I change it back to alternatively for the wind load cases. Yeah, that's all for this dialog. Yeah, design the situations. For ultimate limit state design and 3 for the serviceability limit state design are created. Yeah, and they are assigned to the add-ons, concrete design, steel design. Then combination wizard, I open the options here. Yeah, load combinations are preset since nonlinear effects and results according to second order analysis are only correctly determined by load combinations. Then, yeah, the static analysis settings here for second order analysis. I can go to the dialog here, sub-dialog. You can, for example, use another iterative method. You can change the number or the maximum number of iterations. If you have problem that calculation don't converge, and you can set also the number of load increments higher. So that should be all to this dialog. Then options 2, user-defined action combinations. Yeah, no action combination is created when you check this here, but actions must be combined manually. Then favorable permanent actions. Yeah, additional load combinations are created. For example, combination for design of lifting. So then reduce number of generated combinations. That's a quite powerful tool with a workflow. I can explain it with a simplified workflow. All load cases are calculated individually based on the calculated values of internal forces and moments, deformations and reactions. You get 2 groups of load cases for each location. And one group contains the load cases with positive values, and the second group includes the load cases with negative values. And then the load cases with permanent loads are combined on the one hand with the load cases from group 1, and on the other hand with the load cases from group 2. I will try this option in this model here and also on another model. So then standard options. Yeah, the options are adapted to the standard. Yeah, in this case here, Eurocode 0. And for example, it's possible to neglect certain constellations. You can see that here. But one hint from my side, please check the criteria's validity before changing any of these standard options. Okay, that's all for the combination wizard. Then we come back to the design situations. Yeah, default is the second order analysis, but I can change the option to first order analysis or geometrical linear in one step. I selected all three with the shift key here and assign the geometrical linear analysis. Okay, then for the ultimate limit state design, I activate both add-ons for the serviceability limit state design characteristic as well, but for the frequent, I activate only concrete design, and for quasi-permanent, also only concrete design. So did I forget? Yeah, okay. I would like to show you this option here. Consider inclusive, exclusive load cases. So you can select one load case or more load cases and define that it or them or they only are combined with certain load cases. Or you can exclude load cases. So you select load cases and they don't have to combine with selected load cases. I don't use that option here. So then action combinations. Yeah, as the name suggests, actions are combined now. For example, from action combination 3, we will get 4 load combinations, since there are 4 wind load cases in action category 3. So here, action combinations that are not relevant are set inactive by default. You can see 5 action combinations are inactive. So that means we have got 19 action combinations minus 5 means 14 action combinations, and we will get 37 combinations. 16 for the ultimate limit state design and the rest for the serviceability limit state design. And here left above with that button here, it's possible to create or to add combinations manually. So let's take a look again to the design situations. We can click here on overview, the assigned load combinations, characteristic, frequent, quasi, permanent. So let's try to reduce the number of generated combinations. We've got 16 load combinations for the ultimate limit state design. I go in the combination wizard and set the check here. So, and go to the load combinations. As I said, 6 load cases are calculated at the moment. And we have got 16 load cases, no reducing. That can be, just try it. And sometimes it don't reduce the number of combinations, because all the load combinations are important for the calculation. I will try that on another practical example later. So then I would like to show you the structure modification on this example. Let's calculate combination number 9. So that contains only the self-weight and the snow load. I displayed the internal forces, the My. So, and as you can see, the moment curve is quite symmetrical, almost symmetrical because of the imperfection. And I would like to reduce the stiffness of this column in that load combination. How to do that? I go back in the load cases and combinations dialog, go to load combination 9, and check here structure modification. And we have to create a structure modification. There are different options. You can modify the stiffnesses of material, section, members, nodal supports. You can deactivate objects, members, surfaces, supports, and so on. I would like to reduce the stiffness of a member. I have to create the member modification here. New member stiffness modification. I use the modification type multiplier, factor, or total stiffnesses. You can see here that you have got different options for the American standard and Canadian standard and so on. Okay, I enter 0.1 means the stiffness or the total stiffness is only 10% after the modification. I have to select the member, the right column. Okay, and can calculate the combination. And as you can see, the moment curve isn't symmetrical anymore, because this column has only 10% of the stiffness. Okay, that's all for this example. I switch to the next example. Now that's a quite practical example. I think I created that and used it for the webinar 3 weeks ago. And let's try the reduction of the combinations. So ultimate limit state design. Let's take a look at the load combinations. We've got 26 load combinations for the ultimate limit state design. So, and for this design situation, I go in the combination wizard and check the reduce number of generated combinations. So then the same workflow. The 6 load cases are calculated. Then the combinations will be created. We've got, or we had 26. And after the reduction, we have got 10 combinations. Okay, as you could see, sometimes you can reduce the combinations, sometimes not. That depends on your models, on your number of load cases and number of load combinations, etc. Okay, then I can leave the dialog and turn to the next model. This is also a model from a webinar, the geometrical analysis. So, and you can see the model here. with a nonlinear solid model with different stiffnesses in various load situations. And we would like to consider the soil's initial stiffness that is loaded by the self-weight. So before I go in the dialog, I go back in the PowerPoint. Yeah, this curve here is quite important. We start the calculation at this point. We consider the initial stress with caused by the self-weight of the soil. And what I have to say, only internal values are transferred in the initial state, such as stresses, strains, stiffnesses. And both the initial stiffness, that means that, and the stresses are considered. And regarding the stresses, it's important to have the total stresses in the structural system, because only then the right stiffness is used. Okay, as I mentioned, we start the calculation here, and that's the end state here. Okay, let's go back to the program. We go to load combinations, dialog. So we have different load cases, self-weight of the superstructure, dead load, live load, snow, and the self-weight of the soil. And the self-weight for soil solids is activated. This is this action category. Now it's not necessary to calculate this load cases, only later in the load combinations. So then I showed the combination wizard, and it's checked consider initial state from load case 5, self-weight of the soil. Okay, then we get 2 load combinations, and the load combination 2 is decisive. So, and we created result combinations, one result combination. The load combination 2 minus load case 5 means we subtract the load case 5 from the combination 2. That won't be necessary in the future. We work on it, but at the moment we solve that with creating a load combination. Okay, let's take a look at the program or at the graphic. Load case 5, we get global deformation of 177 millimeter. Let's take a look at the clipping plane. You left both. There are clipping planes. I activate this one so I can rotate it. So, and as you can see, the building here hasn't any influence for the self-weight of the soil load case, but then in the combination 2, the deformation of the self-weight and the deformation caused by the building is added, and you can see a global deformation 195 millimeter, and then we subtract the self-weight load case, and now you can see the right deformation under the building, 30 millimeters. Okay, that should be all to the initial state. I turn to the last example for today. I would like to show you a model with result combinations. I open the dialog here. So, and as you can see, the result combinations are activated, and also the sub-results. Standard for the combination wizard and classification is the Eurocode 0 again, and the German National Annex. So let's turn to the load cases. Load case 6 for modal analysis, and load case 7 contains the results from modal analysis for spectral analysis. Then the actions. Action 4, seismic action, and load case 7 for the spectral analysis is assigned. So then design situations. Design situation 1 for determination of mass combinations for modal analysis, and the design situation 2 for accidental design situation for seismic load in the ultimate limit state. And when you select, for example, or activate the steel design or concrete design, then you need to activate them here for the ultimate limit state design. So then, the different combination wizards here, design situation 1 for load combinations, and design situation 2 for result combinations. Then action combinations. Action combination 1 creates load combinations, and action categories 2 and or action combinations 2 and 3 create result combinations. So then we have 1 load combination and 2 result combinations. A new feature in RFEM 6 is that the result combinations are automatically created. You can see that. And what I need to say, at assignment, you can see the selected or assigned load cases, and I activated sub-results, and you have the possibility to superimpose also other partial results here. Okay, that was the example for the result combinations. That's all for today's webinar. I promised to show you our website where you can find the previous webinars. Let's turn to our website, dlubal.com. Before I show that, I would like to mention, I switched the language to English, the option to download our free trial version. It's a full version for all attendees that work with our programs at the moment. You can download the trial of RFEM 6 and RSTAB 9 here, our section, our wind, etc. And for example, RFEM 6 and RSTAB 9 contain all add-ons, a full version, and it's usable for 90 days. So then under news and events, you find our webinars, and you can select, for example, program version RFEM 6 here, and the product, for example, structure stability search, and you will find a webinar. Or I mentioned the construction stages analysis. I search for it. Okay, there are 2 webinars. I meant this one here, consider construction stages in RFEM 6, but we used it also in the form finding webinar. And you can also do a full text search where I enter stability, for example. Yeah, and you will find more webinars. This one, and also for the analysis of steel joints, the stability analysis is considered. Okay. Yeah, that's all for today's webinar. Thank you for your attention. Thank you, or thanks to my colleagues for answering your questions. Maybe one additional hint: when you leave the webinar, there is a small survey. It's quite important for our quality management. I think it takes only 1 minute to answer some questions. Would be very kind if you take the time. Yeah, I wish you a nice rest of the day, and yeah, maybe an additional information for the survey: the worst score is 1 and the best score is 5. Yeah. Okay, but now that's all. Thank you for attention, and bye-bye.